Hi, so let's build this polyphonic synth in Max. So let's start Max here, create a new program, and I'm going to hit Command M to see the Max console. And we're going to actually start inward. Remember I told you that in C++ you would have a struct for each voice of the synth and then a class holding an array of those structs. That would be your actual keyboard. So in Max, we're going to have an encapsulated program that is going to run the voice, and then an object within the main program that is going to call each of these voices. So in order to have polyphony, we're going to use this little object called poly_MIDI_in. So poly_MIDI_in. Okay, and this is going to be our entrance to this encapsulated portion of the program. Now let me just, instead of snapping to objects, I want to snap to the grid here. Okay, so poly_MIDI_in is, we connect that to a MIDI parse object. So in order to create a new object, we hit N, so the key N, so MIDI parse. So MIDI parse is going to, a MIDI message is composed of several parts, note, velocity, which is which controls the amplitude of your overall message, and also a lot of control messages like panning, volume, aftertouch, and all sorts of things. So we're going to parse this big message and using this object here. And the first outlet of this object consists of a list containing pitch and velocity. So we're going to separate those further with an unpack object. So unpack is going to take that list and separate it, with its two outlets. So the first one is going to be the first element of the list, which is going to be note, and the second one is going to be the second element of the list here, which is going to be velocity, like pitch and velocity. Okay, so the note comes as a MIDI note, so we have to convert that into a frequency. So we use another object called M2F. Right, so M2F performs a simple operation that converts a MIDI note into a frequency that we're going to use. And now we're going down this path, we're going to create, for now, for this first video, we're going to create a sawtooth oscillator. So a new saw tilde. So whenever you have a tilde, this means that this is a signal, right? Where these are control messages, they run much more slowly than signal messages that run, you see the patch cord is even different. So these objects run at audio rate, so they're more expensive. So the first inlet of saw tilde takes the frequency, which is what was just calculated here based on the MIDI note. Okay, on the amplitude side of things, we're going to use, so MIDI runs between 0 and 127, right? So we're going to, but amplitudes for audio run between 0 and 1. So we're going to pretty much divide this by 127 and put a dot there to indicate that this is a float that we need, and take that velocity from the keyboard and generate a number representing the amplitude that we can use. Okay, the next thing that we're gonna do, but this is gonna just turn things on and off, and we're gonna have audible clicks because there's no smoothing of this turning on and off. So we need an object to control the envelope of the sound. We're going to use a simple ADSR envelope, and ADSR stands for attack, decay, sustain, and release. Later we're going to change dynamically this envelope, but for now we're going to just initialize this object with a 10 millisecond attack, 10 millisecond decay, and then sustain is a measure of amplitude, so we're going to go all the way down to 0.5. So we're going to remove 0.5 is minus 6 dB of the original amplitude, and then let's have a somewhat longer tail of 200 milliseconds, so which is the release, right? So ADSR takes a non-zero argument to trigger and a zero argument to shut down. So we're going to connect this, the first inlet here, since these are all the other control parameters that we're going to automate later, but not now. And then we multiply, in order to impose this amplitude envelope to the signal, we multiply both things together. So we're going to create multiplication. But now the output of these two things are signals. So we need the tilde thingy here to indicate that we're multiplying actually signals. Otherwise, it wouldn't work. Okay, so oops, not where I want it here. So okay, multiplying them together and then send it out of the voice here, out tilde, also tilde because it's a signal now, 1. So out of outlet 1, we're going to send this signal. Now, in order for us to have polyphony, really, we need to tell Max what voices are being turned on and off. Otherwise, there's no mechanism to turn things off, right? So in other words, these the processing of these signal objects are going to be going on and on indefinitely, and that's very expensive. We don't want it. We don't want to do any calculations when the note is actually off. So we need an object called this. In fact, Max won't even allow us to have polyphony until we define these things. So this is necessary. We have an object called this poly. So this poly takes, so whenever this signal here is non-zero, it's going to turn on. So this poly controls turning on and off of this voice. So whenever this signal is non-zero, it's going to turn on this whole voice through this poly object. And then the third outlet of ADSR tilde, which is this object here, sends a message to this poly saying that the voice is done, is finished with the envelope. So we also connect that. So this is going to turn the voice on, and this chord is going to actually turn the voice off. Okay. Finally, we need an object so when we instantiate all those say 128 voices within the main thing, we want to have them all off at first. Otherwise, they're going to all be instantiated with an on state. So we begin before at the time that we're constructing this, each of these voices, we need to tell this poly to be quiet. So we're going to use an object here called load mass, which loads a message whenever this whole thing is instantiated, and we're going to say mute and 1. Mute 0 would be no, do not mute it, and mute 1 means do mute it. So we're going to just start by giving this message to this guy. That's the reason why. So let's go ahead and save this as voice. So this is going to be our voice batch. Okay, cool. Now create a new one that's going to hold all those 128 voices. So, oops, no, I meant to open the Max console. So in here, in order to create those 128 voices, we're going to actually create an object called poly tilde, right? Which manages polyphony and DSP for patchers, right? And then we're going to say which voice are we going to use? We're going to use our voice here. And how many voices do we want? Let's start with, say, 64 voices, okay? So, cool. So, warning, you have multiple files. Yeah, I could. Let me see. Yeah, no, we're good. Okay, so this is the voice. This is the poly tilde. And there will be sound coming out of this thing, right? And so we're going to connect this to a gain object, say live.gain. Oops, live.gain. And then right now this is a mono synthesizer, so we're going to connect both outputs. Oh, I hate the snap to objects. Let's snap to grid instead. All right, so we have a live.gain here, and then we're going to send it out to the speakers. Let's use EZ DAC, or digital to analog converter. Okay, and we're going to connect both outputs to our speakers there. Okay, now we need to receive MIDI messages and send them to this poly message, to this poly object here. So we're going to use an object called MIDI in. So no object MIDI in, and MIDI in is going to send all sorts of MIDI messages through this outlet here. So we need to use yet another MIDI parse object, and select only the events, the actual MIDI event that we want to send to the synth. Okay, and so this is how it works. So right now, if you close your patcher, or the shortcut would be Command E, right, and or this little lock here. So when you close your patcher, you're out of edit mode, and now you can sort of double click here and see a list of all your MIDI controllers that you have connected to your machine. So if I select my mobile case here, I should probably get some sound. Okay, now it's kind of tedious to the user to double click this thing, so we want something a little more informative. So we use a little object here called MIDI info. So MIDI info, and MIDI info is gonna ask the system what kind of controllers we have connected. And we want this to happen as we instantiate, as we construct this whole thing. We don't want to, have to double click here. So we're going to create another load message object, and this time we're going to pass inside of the poly here. Remember we said mute one, right? But here we're going to say controllers. So this MIDI info box takes different arguments, obviously. So controllers, and so we want to know right from the start which kind of controllers we have connected to this machine, right? And then we're going to use that to populate a little menu. So this is already a user interface object that we're going to explore further when we build the user interface around these things. So it's called U menu. So user menu is an object that is going to take the list passed out of MIDI info, and out through this outlet it's going to output the numbers, and out of this outlet it's going to output the actual text, the actual string that it gets from the MIDI info. So that's the one we're going to need, right? So whenever you open this list is going to be populated, or we can force it to be populated by double clicking here. So now we see Max, and we can choose mobile keys, and then if you choose something else, and then it's not going to work, and then we choose this back again, and it works. Okay, in the next video we're going to see how to create other waveforms besides just the saw, and how to select them from this main patcher here. All right. Oops. Where's my quick time? And please don't tell me I haven't been recording this thing. And where's my MIDI? Where's my recording again? Oh, there it is. Okay, sorry.